Good morning, students. Welcome to your new unit. On this unit, we're going to be talking about quadratic functions and graphing of quadratic functions, along with shifting of quadratic functions. Here's your bell work for the day. Go ahead and pause your screen. You are going to label numbers 1, 2, and 3 as either linear or quadratic functions. So today we're going to be talking about the vertex form equation to describe our parabola. So just like we learned y equals mx plus b for linear functions, we have y equals a times the quantity of x minus h squared plus k, and this is going to describe our vertex form of our function. So sometimes you'll see y denoted also as f of x. So we're first going to start by talking about what these coefficients mean, these variables rather mean. So we have h and k right here, where h comma k is the vertex. H comma k is the vertex, which is the highest point of a parabola. So this point right here would be our vertex in this equation. So one thing to note is that it is negative h. So if our h is positive here, we're going to want to make sure that we still have a negative sign here. Next, let's talk about the coefficient a. So a is a constant, h is a constant, and k is a constant. All of those will become numbers, while our letters in blue will stay letters. The only letters we want when we're graphing a function are y and x to be still letters in the equation, while a, h, and k will become numbers. So over here we see that a, if it's less than 1, then our parabola is facing down. So this right here would mean our a is less than 1. A would therefore be less than 1 because our parabola is facing down. If our parabola faces up, then we have our a is greater than 1. So a is going to be any number. It's a constant, but if it's less than 1, our parabola faces down, and if a is greater than 1, our parabola faces up. One common way that you will also see quadratic functions be written is y equals ax squared plus bx plus c. But this doesn't tell us as much as our vertex form equation, because yes, these are all just coefficients, but it doesn't give us any information about the vertex. So to convert from our quadratic formula here into our vertex form here, you want to be able to solve for the coefficient a, and you also are going to need to know a couple of things about the equation. So we're going to be flipping back and forth from this board right here into Desmos. So let's say we know that y equals 2x squared plus x plus 5. Here you can see the graph of this function, y equals 2x squared plus x plus 5. Now, we can probably eyeball this vertex really well right here, but just to make sure we're doing it correctly, I wanted to show everyone how we can solve for that. So to find the vertex, all you have to do is click on your line, and it will give you your vertex coordinates right here. But make sure you don't mix it up with this one, because that is showing you the y-intercept. So we want to make sure that we know that it is the vertex, because it is the point that is in the very middle of our parabola. Okay, so after we find our vertex, we can solve for the line of symmetry, which is x equals negative b over 2a. All right, and our a value is going to be what? Well, our a value is the coefficient before x squared, which is 2. Our b value is our coefficient before x, which is 1, because there is no coefficient before x, so we know that that is 1. And our c value is 5. So our line of symmetry is going to be equal to negative 1 over 2 times a, which is 2, and then we get x equals negative 1/4. So we can go back over to Desmos and graph a second line, x equals negative 1/4. And that should show you the line axis of symmetry that cuts directly into your parabola. Now that we have our line of symmetry, we also can say that the x value at negative 1/4 is the point of our vertex. So if you're solving this without Desmos, you're going to have to go back into our problem here and remember x equals negative 1/4. So we're going to erase all the rest of this stuff really quickly. So now we're solving for the y value where x equals negative 1/4 to find our vertex. If you don't have a graph, this is a better way to do it. So for y, we don't know what that is. We're looking for the y value at x equals negative 1/4. So we're going to plug in negative 1/4 for all of our x values. And that will give you the y coordinate of our vertex, which if we go back to our Desmos, we already know that that y coordinate is 4.875. So go ahead and solve for that. You would get 4.875. All right, now that we have our y coordinate and our x coordinate, we know how to convert it into our vertex form. So let's erase this again. Okay, so for our vertex form, we had y equals ax minus h squared plus k. So when we have y equals negative y equals, hold on one second. Okay, so we had y equals a x minus h squared plus k. Well, we found from before our vertex is at x equals what again? If you forget, just go back. We know x equals negative 1/4. So here we know x equals negative 1/4. And our y value at that point was 4.875. Okay, so now we know we have 4.875 as our h, comma, k. So if we're rewriting this in our form, we know y equals a. We still need to solve for a. X would be our negative 1/4, but we don't use that. It just stays as x rather, and our x value for our vertex goes into h, so x minus 1/4 squared plus our k value, which is 4.875. Now we need to solve for a. Well, the good news is we already have an a value from our original equation, which was 2. And I wanted to remind you that since this is negative, we have to have a positive here, so make sure you change that. And so here is our equation in vertex form from our standard quadratic formula, x plus 1/4 squared plus 4.875 equals y. And to check yourself, you can go back into our Desmos calculator, plug in your vertex form, and ensure that the lines cross over. See, they are crossing over. I can show you that. Plus 4.875. And there you go. They cross over. So another trick that we're going to learn on Desmos is we're going to click right here and we are going to click here. That will give us our table set. That gives you automatic coordinates for this table. Okay, but I want to warn you guys that I am going to ask you to show your work a lot of the time. So although this is a great way to check your work, it is not always the most beneficial to doing great in the class. So make sure that you really understand how to convert from these two equations, and we will work out some practice examples in our assignment this week. Stay tuned for the exit ticket shortly after this clip. And here's your exit ticket for the day. Go ahead and pause your screen to complete 1 through 3 on your exit ticket. If you have any questions, as always, reach out and have a wonderful rest of your day.